తెలంగాణ రాష్ట్ర ప్రభుత్వ సహకారాలే ఉండగా హాయిగా మన చదువులు షురు. అదే డిజిటల్ గురు, అదే డిజిటల్ గురు.
Hello students, welcome to digital classes. Children, before we begin the class, I want you to observe this bottle and spoon and fork. Just see how beautifully the spoon and fork are balanced. Even if you disturb a little also, it is not going to fall down. In the earlier class, we have discussed how planets go around the sun. We also discussed that centripetal force is required for uniform circular motion. Also, we have seen that centripetal acceleration is v square by r. Let us have a look at what we have learnt in the earlier class. The force which is necessary for an object to be in uniform circular motion is called centripetal force. We have seen that the velocity is always perpendicular to the radius of the circle and the centripetal force is mv square by r. We have seen universal law of gravitation which says every object in this universe attracts every other object in the universe with a force directly proportional to the product of masses and inversely proportional to the square of distance between them. The gravitational force of attraction between two objects is given by F equal to g m1 m2 by r square. We have also seen that the gravitational force is always an attractive force. It is a long range force, it acts over distance of crores of kilometers. Universal law of gravitation is a universal law, also it is a theoretical law. In today's class, we will discuss centripetal force a little more in detail. Also, we will discuss how the objects fall and the equations of motion during the free fall of an object. Also, we will see some interesting concepts in gravitation. Children, let us do an activity to demonstrate centripetal force once again. I take a tray and a glass marble and I will put in this and you will see the glass marble is moving along the circle. This is because centripetal force was provided by the normal reaction from the walls of the tray. So, we have understood that centripetal force is necessary for uniform circular motion. Children, also observe this. If the velocity is not enough, the object comes back or it falls down. So, the last it left from this height because the velocity was not enough, the gravitational force was more than centripetal force required, hence the ball fell down. So, at this point the gravitational force is more than centripetal force and hence it falls down. So, we have understood that centripetal force is necessary for circular motion. Now, let us do a numerical related to centripetal force. A car moves with a uniform speed of 10 meters per second on a circular path of radius 20 meter. How much is the required centripetal force if the mass of the car is 1500 kg? So, here is a car which is moving along a circular path. A centripetal force is required for the car to move in the circular path, so that it can move along the circle. Now, let us solve. Here the mass of the car is 1500 kg, the radius is 20 meter and the speed with which the car moves is 10 meters per second. The required centripetal force is mv square by r. So, let us calculate. Substituting the values, 1500 times 10 square divided by 20 is the centripetal force. Simplifying it, we get the centripetal force required is 7500 Newton. Children, so we have seen in this question a car was moving along a circular path. Now, if the roads are flat, then the friction provides the necessary centripetal force, but you see always the friction cannot provide enough centripetal force. So, two-wheelers and cycles, when they are driving, they bend when they are taking a turn to go this way, or to take a turn this way, the vehicles bend this way. If the roads are flat, then only friction provides necessary centripetal force, but this friction will not be sufficient to provide enough centripetal force. Hence, the two-wheelers bend while they are moving on a curved path. Here we can see a person who is participating in a race along a curve. To negotiate the curve, the person bends the two-wheeler and surprisingly he does not fall, because centripetal force is provided by the gravitational force. Here is another photograph where the people are racing and use so that the vehicles take a turn easily. Here is the photograph of a road which is banked, the outer edge is raised. Children, now we have understood that centripetal force is necessary for making a circular motion. So, for planets, the gravitational force provides the necessary centripetal force so that they can go around the sun. So, the planets move around the sun with the help of gravitational force. Gravitational force provides necessary centripetal force for the planets to revolve around the sun. Children, now we have discussed that every object in the universe attracts every other object. Now, we all should wonder why the objects, for example, this laptop, this glass, why do not they attract? Or we see so many objects around us, when the universal law of gravitation is true, why do not we see the objects attracting each other? Why do not we observe the gravitational force between the objects? So, let us find out why the objects are not observed to be attracting each other. Let us calculate the gravitational force between two objects. So, two objects each of mass 1 kg and the distance between them is 1 meter. Here the gravitational force of attraction is given by F equal to g m1 m2 by r square. Substituting the values, we get F equal to 6.67 times 10 power minus 11 times 1 into 1 divided by 1 square. So, here the force is 6.67 into 10 power minus 11 Newton. Here g, which is 6.67 into 10 power minus 11 Newton meter square per kg square, is the universal gravitational constant. This force between two objects is very less. In decimals, it is 0.10 zeros and then 667 Newton. So, the gravitational force between two objects is very small to be identified. So, we do not see them. Then why is that we are able to see the objects falling down to the earth is the question. Let us calculate the gravitational force between any object and the earth. So, consider an object of mass 1 kg and earth. The distance between them must be the distance between the center of the earth and the object. So, the distance should be equal to radius of the earth. Now, mass of the earth is 6 into 10 power 24 kg, that is huge. So, the gravitational force is equal to F equal to g m1 m2 by r square. So, here m1 is mass and m2 is mass of the earth. So, substituting F equal to g mm by r square. So, we get F equal to 6.67 into 10 power minus 11, 6 into 10 power 24 into 1 divided by 64 lakh square. The radius of the earth is 64 lakh meters. So, the value of the gravitational force comes out to be 9.8 Newton. So, we have two objects here, the gravitational force between them is very less, that is 0.10 zeros and 667, whereas the gravitational force between the object and the earth is 9.8 Newton. Because the gravitational force between the object and the earth is more than the gravitational force between the objects, we do not see the objects around us attracting each other. So, the force of attraction between any two objects around us will be much smaller than the force of attraction between the object and the earth, and hence the gravitational force between the objects and the earth is more dominant, and hence in front of that force the force between any two objects is quite negligible. Hence, we do not observe the objects attracting each other. Now, when every object is attracted by the earth by gravitational force, this force should produce an acceleration. Let us demonstrate an activity. So, children, in this activity we have seen that the velocity of the object was increasing during its free fall. So, as the object is falling down, its velocity is increasing with an acceleration. So, let us find out the acceleration. The acceleration due to gravity on an object. Consider an object of mass m. The gravitational force on this object due to earth will be g capital M times small m divided by r square. This force will produce an acceleration, and from Newton's second law this force must be equal to m a. So, substituting we get g m by r square equal to acceleration. M and m will get cancelled. So, the acceleration due to gravity is g m by r square, where m is the mass of the earth, r is the radius of the earth. This acceleration is called acceleration due to gravity. This acceleration due to gravity is, which is g m by r square. Calculating the values, we get g equal to 9.8 meter per second square. Children, so we have calculated that acceleration due to gravity is equal to g, that is universal gravitational constant, times mass of the earth divided by square of the radius of the earth. And surprisingly, the mass of the object is not present in the formula of acceleration due to gravity, meaning to say, irrespective of any mass, every object is accelerated towards the center of the earth at the same rate. That means, if we have any two objects, if we drop them, they are supposed to fall down or reach the earth from the same height in the same time. Often it is not observed due to various factors, which we will discuss after this activity. Children, let us do an activity to demonstrate that objects should fall in same time from the same height. Let us do. Will you agree that both the objects reach the table in the same time? Watch it. Not. As you guessed, paper did not fall down in the same time as this ball. We will do with another set of ball. Let us try our luck with these two objects. When we drop, both of them should reach this table in the same time. Universal law of gravitation says that, but let us see. Even these two did not reach in the same time. We will try with this. Let us try our luck with this. Even these two did not reach in the same time. Now, children, we should provide nature the conditions so that the experiments do not fail. Here the experiment did not fail, here the activity did not fail. What we have not taken into account is the air resistance. I still say this paper and this object should reach in the same time. Now, I will do some magic and this paper and this ball will reach in the same time. Shall we? We can take this ball or any ball for that matter. This paper and these balls will reach the table surface in the same time. Yeah, abracadabra. So, the paper is going to reach the same time with this ball, right. It is the same paper. I am going to crumple it. Now, let us see, there it is. I have crumpled the paper and now they are going to reach in the same time. Yeah. So, with this activity we have demonstrated that every object should fall down from the same height in the same time. But what happened in the earlier case, when the paper was full, it is because when the paper was like this, it did not reach in the same time with the ball. Because of air resistance, the paper is falling like that. And when we crumple it, the air resistance is less, and hence the effect of air resistance was not seen on the paper. Galileo has demonstrated an activity to show that all objects, that is of different masses, should be accelerated at the same rate. That means, all objects fall down from the same height in the same time. So, Galileo has done this activity from Leaning Tower of Pisa. Galileo is said to have dropped two spheres of different masses from Leaning Tower of Pisa to show that their times of descents are same. So, he dropped two objects of different masses and both of them fell down in the same time. Children, let us do an activity to demonstrate the same. Children, we have understood that acceleration due to gravity is same for each and every object, and the direction of this acceleration will be towards the center. Acceleration due to gravity will always act towards the center. If we throw an object vertically upwards, it goes up high and then comes down. Now, let us see what happens on different parts of the globe. Now, consider 4 men on the earth. Actually, there are more than 7 billion people. This person throws an object upwards. This object will fall down in this direction. Imagine another person throwing a ball up. For him, up will be towards right for us. For him, that is up, which is given by the arrow, and the ball returns to the ground. Similarly, another person throws an object upwards, and for him the object returns in this direction. This person will throw the object upwards and the ball will return in this direction. So, at any point on the globe, the acceleration is always directed towards the center of the earth. Now, children, let us find out how much time an object takes to reach its maximum height when it is thrown vertically upwards. Let us find out. Consider an object being thrown vertically upwards. At the maximum height, the velocity will be 0, and then the object starts falling down. Let us find out how much time the object takes to reach that height. An object is thrown vertically up with a speed of 20 meters per second. Find the time taken, also the maximum height. Here the acceleration is minus g and the final velocity is 0. So, using the equations of motion, v equal to u plus a t, the final velocity is 0, hence we can substitute that 0 equal to u minus g t. So, t is equal to u by g. This is called time of ascent, the time taken by the object to reach the maximum height. So, let us calculate. T is equal to u by g. So, substituting the values, 20 by 10 equal to 2 seconds. So, the object takes 2 seconds to reach the maximum height. Now, let us find out the maximum height reached by the object. For that, we have to use the equations of motion again. We will use this equation, that is v square minus u square equal to 2 a s. In that, acceleration is minus g because the direction of acceleration is towards the center of the earth while the object is moving up. So, substituting the values in this equation, 0 minus u square is equal to 2 times minus g times h. Here h is the maximum height reached by the object. So, we get minus u square equal to minus 2 g h is equal to u square by 2 g. Now, let us study the motion of the object as it falls down. Consider an object which is dropped from a height. Now, the equations of motion can be written as follows. Here the acceleration is g because the object is falling down and the acceleration due to gravity are in the same direction. The initial velocity is 0 and the distance it falls down is h. So, v equal to u plus at. So, v equal to gt. S equal to ut plus half at square can be written as h equal to gt square by 2. V square minus u square is equal to 2 a s, comes out to be v square equal to 2 g h. Children, now let us find out the velocity of the object after it is dropped from a height at different points of time. So, consider an object which is dropped. After 1 second, the velocity will be equal to 10 times 1, that is 10 meters per second. V is equal to gt is the formula which we have used, and hence after 1 second the speed of the object will be 10 meters per second. After 2 seconds the velocity will be equal to gt, which is 10 into 2, that is 20 meters per second. After 3 seconds the velocity will be equal to v equal to gt, which is 10 into 3, that is 30 meters per second. So, if we calculate, we get after 1 second the velocity will be 10 meters per second. After 2 seconds the velocity will be 20 meters per second, and after 3 seconds it will be 30 meters per second. After 4 seconds 40 meters per second and 50 meters per second after 5 seconds, and similarly we can calculate for 6 seconds and any other time interval also. So, this table gives us the velocity of the object as it falls freely under gravity. Children, now let us revise. The force which is necessary for an object in uniform circle is called centripetal force. Centripetal acceleration for an object which is in uniform circular motion is given by A equal to v square by r, and we can calculate centripetal force which is mass times acceleration, which will be equal to m v square by r. The velocity of the object is always perpendicular to the centripetal force. The centripetal force is always directed towards center of the circle and is given by m v square by r. We have discussed universal law of gravitation. Every object in this universe attracts every other object in the universe with a force directly proportional to the product of masses and inversely proportional to the square of the distance between them. The force of attraction between any two objects in this universe is given by F equal to g m1 m2 by r square. Acceleration due to gravity is g m by r square, and its value is 9.8 meter per second square on the surface of the earth. All objects will reach the earth from the same height if air resistance is ignored. When a person throws an object upwards, it reaches down, and similarly at all places on the globe. So, wherever we are on the globe, whenever we throw an object upwards, it will always reach the earth. When an object is thrown vertically upwards, acceleration of the object is minus g, and the maximum height reached by the object is h equal to u square by 2 g. The time of ascent t equal to u by g. When an object is freely falling, the acceleration is g, the initial velocity is 0, distance it falls is h, then the equations of motion will be v equal to gt, h equal to half gt square and v square equal to 2 g h. Children, we have come to the end of this session. we have discussed centripetal force, universal law of gravitation and acceleration due to gravity and few other concepts. What I want you people to do is take the textbook, work out the numericals given in the exercise and discuss the same concepts with your friends, and if you have any doubts, get them clarified by your teachers. Children, I want you to observe this bottle and spoon and fork. Just see how beautifully the spoon and fork are balanced. So, fix the spoon into the teeth of the fork this way, and then using a matchstick we can balance it on the glass tumbler. See how beautifully the spoon and fork are balanced on the glass tumbler. Even if you disturb a little also, it is not going to fall down. Children, I will explain how it works in the next class of center of gravity, and we will meet in another session with more interesting topics. Thank you.
ఆ చదువులమ్మ నేరుగా ప్రతి ఇంటి గడప చేరగా మీ భవితకే భరో